Welcome to today's lesson on communications of reflections. So by the end of the lesson, you should be able to write an equation from a description and describe the transformations for a given equation. So we're going to look at reflections and also review our translations that we had in one of our last lectures. So when we look at the idea of a reflection, okay, we always want to start with our parent function. Today we're going to start with the square root of x function. And we want to see what happens when we put the negative in front. Okay, reflection is a flip of a graph, so we know that this graph is either going to flip vertically or flip horizontally. You want to think about your high-low rule, and what do you think the negative in the front is going to do to the graph? Okay, now I've got the two equations inputted into the graphing calculator. Okay, equation 1 is the traditional square root of x. Equation 2 is the square root of x with a negative out in front. And if we take a look at the graph, the blue line is the original square root of x. The red line is the negative square root of x. So we can see by looking at the graph that it has flipped over the x-axis, but that is a vertical reflection. So if we think about our high-low rules, negative on the outside, outsides are vertical. So when we see this situation, the negative on the outside is vertical. We would call this a vertical reflection. And if we're talking about what line we're reflecting over, this is where you have to be careful. It can also be called a reflection over the x-axis. So the x-coordinate axis is horizontal. So if you're reflecting over it, you're actually reflecting vertically. Okay, now you can probably guess what's going to happen when the negative is on the inside. Okay, we'll take a look at the graph and see what happens with that transformation. So we're going to switch our equation that we have here. We'll put the negative on the inside with the x value. And then now when we look at this new graph, the blue line is the original, okay, and the red line is the transformation. So now this graph has flipped from left to right, okay, so we can see with that arrow, we would call this a horizontal reflection. So we have a negative on the inside. We know insides are horizontal. We've got a horizontal reflection. Or we can also call it, and this is where, things get confusing a little bit at times, so you want to be careful, a reflection over the y-axis. So the one thing you really want to do when you're looking at the reflections is think about how the graph is moving. Is the graph moving horizontally or is it moving vertically? Because the reflection is over the opposite value. Just a reminder of the rules that we've talked about from the beginning. We use this idea of the seven dwarves being wrong. It's not high-ho, it's high-vo. Horizontal's inside, vertical's outside. So when we look at any inside operation, it's affecting a horizontal movement of the graph. Negative on the inside, we move to the right. We have to remember, we don't trust the inside. Positive on the inside, we move to the left. Now, someone might say, well, if I don't trust multiplying by a -1 on the inside, and I would do the opposite, what would you actually do? It would be x divided by -1, and these actually both do the same thing to a number operationally. The fact that it's a 1 is important in that respect. All of our verticals are on the outside of any given parent function. So we've got the negative multiplier on the outside, a subtraction on the outside, addition on the outside. And the good part about outside values is they do what they look like. The negative is a vertical reflection, the minus is a movement down, the plus is a movement up. So now let's go through and look at some of our descriptions. We're going to have some multiple descriptions here just for extra practice of previous skills. So now the negative is, and we always have to think about where is our parent function. Okay, we're looking for the parentheses, looking for the x, and then we're looking for one of our 5 parent functions, x squared, x cubed, square root of x, absolute value of x, and the 1 over x. Okay, so these are the 5 functions that we're working with in this unit. So for this situation, the squared is the parent. So now I've got a negative, I have a plus 3, and I have a plus 2, and I want to be able to describe what those pieces are doing. Okay, the first negative in front is on the outside, so it's vertical. Okay, and negatives are always just a reflection of that graph. Plus 3 is on the inside. Insides are horizontal. We have to remember that we don't trust our inside values. We want to do the opposite. So the opposite of adding 3 would be subtracting 3, and it would move the graph left 3 spots. Plus 2 on the outside. Outsides are vertical. We trust our vertical pieces, so this graph is moving up 2. Looking at our next equation, parent function, we're looking at the parentheses, looking for one of our 5 common. This one is an x cubed graph, so we're always identifying what's the parent and what's being done to it. Negative on the inside, insides are horizontal, so I have a horizontal reflection. Minus 2 on the outside. Outsides are vertical, verticals we trust, so this graph is going down 2. And then our last example here, the absolute value with the x is the parent, and then we are describing what is happening to that original parent function. Negative on the outside, outsides are vertical. We have a vertical reflection. A minus 6 on the inside. Insides we don't trust, so we're going to do the opposite operation of subtracting 6. So a plus 6 would move the graph right 6 spaces. And then we have the minus 2 on the outside. Outsides are vertical, so we have a down 2 situation there. Okay, just more examples. We'll talk through these real quick. Plus 4 on the inside is a left 4. Minus 1 on the outside is a down 1. Okay, our negative is a horizontal reflection. Negative on the outside of the parent. Okay, absolute value is the parent here. We've got a vertical reflection and up 5. And then this last one, we just have multiple pieces being done. Okay, first one, negative on the outside, is a vertical reflection. Negative inside the parent is a horizontal reflection. Plus 4 inside moves the graph left 4. Minus 5 on the outside moves the graph down 5. Okay, now the next thing you're going to be required to do is build an equation based on a description. So what we always want to think about is, where are the places where we can place values in an equation? We can put something outside in front. That's our vertical reflection. In front, inside, horizontal reflection. Inside after the x value, that would be our right-left transformation. And then outside after the parent, that would be our up-down transformation. So now we're looking at what we have. We have a reflected vertically. Verticals are outside, and I need to put a negative on the outside of that graph. For that piece, I have an up 7 transformation. Up down is vertical. Verticals are outside. I trust what I see, so I need to put an outside plus 7. Now, sometimes you might have pluses in front, but that's pretty rare. You know, normally mathematically we like to put those operations after the parent function. And then our last piece that we have is a left 2. Left rights are horizontal. Horizontals are inside. We don't trust what we see operationally. Left should be negative, but when we're building our equations, we have to do the opposite on the inside of our function. So we would put a plus 2 on the inside. Now, this last spot is not applicable. It's not being used. On your Schoology quiz, you would just enter an NA, just knowing that that is a spot that is not being used for this situation. Now, our next equation that we have here, we're using the x squared parent. So you always want to start to build the parent function first. And think about, right now we have 4 spots where we can put things. Outside in front, inside in front, inside behind, outside behind. And we've got our 2 inside positions, and we have our 2 outside positions. And then we look at the operation and see what is being done and where. Okay, we've got a reflection horizontal. We know horizontals are inside. The only thing that reflects a graph is multiplying by a -1 to change those values. So we're going to put a -1 on the inside here for our horizontal reflection. And then we have a translated down 6. So that's vertical. Verticals are on the outside. Head shake rule tells us we trust what we see with the vertical head shake. So we've got the -6 on the outside. So in this case, we actually have 2 not applicable spots. And then when we're writing it, we would want to clean everything up for our final version of the equation as we build through. Last example here, we've got our square root graph. So when we're building the square root, once again, we want to remember where our positions are. You know, kind of remember where the square root symbol stops, because anything underneath the square root symbol is considered an inside value. And we have our operation in front, inside in front, inside behind, outside behind. So now this situation, reflected horizontally, that means the negative is on the inside. Reflected vertically, we have to put a negative on the outside. This is the one graph that you would actually notice both of those reflections, because it would give you a different look overall. Translated right 1, left rights are horizontal, horizontals are inside. We don't trust what we see, so instead of right being positive, we have to enter that as a -1. And then our last operation, down 9, okay, up down is vertical, verticals are outside, the down is negative for that value. Okay, last piece for just a little bit of extra review, okay, matching operations with the proper description. So take a look at this real quick, enter in what you think you are, okay, pause, and then once you've made your guesses, start it back up so you can check your work. So now, number 1, a negative outside. Outside is vertical. Negatives reflect graphs. So it would be a vertical reflection. Subtraction inside. Headshake rule tells us we don't trust what we see, so we wouldn't trust that negative. We would consider it a positive, so that would move the graph to the right. Subtraction outside. Outsides we trust. Outsides are up and down. So if it's a subtraction, it would move it down. A negative inside. Okay, now you want to be careful. A negative is different than subtraction. A negative is a multiplier. So that would be our horizontal reflection. And then our last couple operations that we have here, addition on the outside is a move up, and addition on the inside is a move to the left. And that concludes today's lesson on communicating about reflections and translations.